Okay. So 10-2 probability events. Your objective will be to explain the dependence of events in everyday language and everyday situations, determine the probability of the union of two events, A or B, and the intersection of two independent events of A and B. So there's two formulas. For mutually exclusive events where A and B are mutually exclusive because no outcome is in both A and B, meaning you can't make a probability nor a kind of like inference on an event where you can't have both at the same time. If A and B are mutually exclusive events, then the probability of A or B is equal to the probability of A plus the probability of B. If C is in the event that A does not occur, then you will find the probability of C just by doing 1 minus the probability of A. So an example of mutually exclusive is a spinner, where you can't say what's the probability of getting a 1 and the probability of getting a 2. That's kind of impossible. You have to do one or the other. So that's why it says or. There's no way for you to do to get a percentage where both of these can be what's called have a probability that these both occur at the same time. It's only one or the other. But there is a formula for mutually non-exclusive, which we'll go after when the problem comes up. Okay, so independent events. So D and M are independent because the occurrence of one does not affect the probability of the other. If D and M are independent events, then you can find the probability of what D and M by doing the probability of D times the probability of M. So you can multiply them two together. If they, okay, so that's pretty much the same thing. So an example of an independent event is if you include the spinner and a number cube. So you could find the probability of what you want from the spinner and the probability of rolling a dice. Since one does not affect the other, these are independent events. And then here's an example that it gives you. So what's the probability of getting an odd number on the spinner and finding a probability of a number greater than 4 on a number cube? And then it tells you just multiply the probability of both of those. All right, so let's do an example. Number one, this is probably the hardest one on the actual homework, but it's pretty much exactly the one that you have. So we'll just do it together. If 6 coins are flipped, what is the probability of at least one tail? So you should know that at least means it's greater than 1. So P times A. This will depend. This will be the probability, if I spell it correctly, probability of obtaining one tail. Next, the important thing is that you need to determine the number of outcomes. So the number of outcomes is how many choices do you have if you flip the coin once? You only have 2 outcomes. You either have one, you either get a head or a tail. That's if you flip 1 coin. If you flip 2 coins, you still have 2 probabilities of it being a tail or a head. So that if you flip 6 coins, it'll be 2 times 2 times 2. So 1, 2, 3, 4, 5, 6. So flipping a coin 6 times will give you 64 outcomes. So determining the number of outcomes. Next is, so the way the online homework wants you to do is to actually determine the probability of not obtaining one tail, because it turns out it's easier to find that probability than it is to find the probability of at least one tail. So a one tail is easier Then determining the outcome of at least one tail. So the only way, so I'll do correct. So only way to obtain no tail is by determining the probability of all the outcomes of all being heads on all 6 coins. Okay, so how does that look like? So the probability of obtaining all tails, sorry, all heads, not tails. Maybe fix this on my notes. Is 1 out of 64. And this is probability of A prime. So probability of obtaining one tail, and the opposite of that is obtaining all of them being heads, is 1 out of 64. So then we're going to use a formula right here that says if C is in the event that A does not occur, then find the probability of C is equal to 1 minus the probability of A. So that's all we're going to do. So the probability of A is equal to 1 minus the probability of A not. So we just plug it in. 1 minus 1 out of 64. Combine like terms. And you'll get 63 or 64. That's the probability of obtaining at least one tail. And that's how you solve number 1. Number 1 is honestly the hardest one out of all of them. The rest of them are a little bit more straightforward. All right, does anyone have any questions on number 1? I'll give you guys a minute to write it down so that we guys, so I'll come back to this part and then I'll give it a minute and put it to the right. Okay, so number 2, it says if the probability of rain is 0.6, the probability of fog is 0.35. The probability of rain and fog is 0.25. What is the probability of rain or fog? So for you to solve this, you're gonna have to draw what we call the draw pictures principle, because it'll help you on how to actually solve it. So that one is C. For all the homework, it's C. So for number 2, it's just C. So if you draw a picture, we're gonna draw a diagram, right? You guys have all been used to the Venn diagram. It's pretty much exactly the same thing. So the probability of rain is 0.6. The probability of fog is 0.35. And the probability of it being rain and fog is 0.25. Now, it's an or, so luckily you already have the formula for it. So for mutually exclusive, if I spell it correctly, exclusive formula, it's in the very beginning. So probability of rain or fog is equal to the probability of rain plus the probability of fog. Now, this problem is non-mutually exclusive, meaning you can actually have a probability of it being both rain and fog. So because it can rain and and there could be fog at the same time. So there's actually a different formula for that. So the probability of rain or fog is equal to the probability of rain plus the probability of fog minus the probability of rain and fog, since both of those can occur at the exact same time. So this one's not in the very beginning notes, but this formula does come up depending on your situation. In this case, you can have rain and fog at the same time. So you're actually gonna have to use a non-mutually exclusive formula. And all you gotta do is just plug in what you know. So the probability of rain is 0.6. The probability of fog is 0.35. And the probability of there being rain and fog is 0.25. All you have to do is just subtract. And you'll get 0.07. And that would be your answer. This one for sure will be on your test. So make sure you just follow the formula. And then for non-mutually exclusive. So I'm not going to tell you it's mutually exclusive or non-mutually exclusive. That's what the part you have to figure out. Is there a probability that I can have both outcomes? And if it's true, you use this one. If it's not, then you use this formula. Okay, so that's number 2. For 3 and 4 says a pet store has 9 puppies, including 4 poodles, 2 terriers, and 3 retrievers. If Rebecca selects 1 puppy at random, the pet store replaces that puppy with the puppy of the same breed. Then Aaron chooses a puppy at random. Find the probability that they both select a poodle. So this is a and, not an or. So this is a and problem, not or, because you want to find the probability that Rebecca selects 1 puppy and the probability that Aaron selects also a puppy. So this will be an and problem. So the formula for that, so probability of Rebecca and Aaron choosing a puppy is, according to the note, is the probability that Aaron chooses Rebecca choosing a puppy times the probability that Aaron chooses a puppy. So it's just multiplying. So the outcomes, there's only 9 possible outcomes because there's 9 puppies. And there is possibilities, there's 4 poodles. So that means if Rebecca, what's the probability of Rebecca choosing a poodle? 4 out of 9. What's the probability of Aaron choosing a poodle after whatever poodle that Rebecca chooses, it gets replaced? So it's still 4 out of 9. So then all you gotta do is just plug it into the formula. 4/9 times 4/9 gives me 16 over 81. If it asks you for a decimal, I think it's asking for a decimal, so you actually have to divide. So this would be 0.198. This will also be on your test. You should know how to find the probabilities of independent events. So just follow the formula and you should be fine. Okay, number 4, use the addition rule to solve the given problem. So the probability of E is 0.3, the probability of F is 0.5, and the probability of E or F is 0.4. Then what is probability of E and F? So this is a non-mutually exclusive problem. Why? It's because there's this is or, and the fact that tells us that there's an and, that means it's non-mutually exclusive, because the formula for non-mutually exclusive problem is a probability of E or F is a probability of E plus the probability of F minus the probability of E and F. There's no way to solve for the probability of E and F if we don't have the probability of E or F, because we're just gonna be plugging it in. Because the probability of E or F is 0.4, probability of E is 0.3, probability of F is 0.5 minus the probability of E and F. So that's what we're solving, because that's the only thing we're not giving. Everything else we're just given, and all we have to do is just solve for the variable. So 0.4 is 0.8. Subtract. Divide by negative F, -1. So this is 0.4 for the probability of A and F. And then that would be the answer. There'll be one like this on your test as well. It'll give you different probabilities. It's gonna ask you to find what it's missing, and you just use one of the two formulas, or three in this case. So just know what you're given, and then you'll be able to find out which one's the one that you're missing. Number 5, or sorry, 6. It says you donate 8 baseballs to a local baseball team. Your uncle donates 12 baseballs. If a total of 50 baseballs are donated, what is the probability that the first pitch of the season uses one of your baseballs or one of your uncle's baseball? This or is a hint to tell you whether it's mutually exclusive or non-mutually exclusive. Right, now we have to use kind of our thinking skills of whether it's mutual, whether you can have the opportunity of being in both, or it has to be one or the other. So the fact is, it tells us that the first pitch, meaning there's only one pitch, meaning that whatever baseball they pick, it can either be your uncle's baseball or your baseball. It cannot be both. So that means this is mutually exclusive, because there's no possible way that the first pitch will be both your or your uncle's baseball. So this is an example of mutually exclusive. There's no possible way for it to be both, for both to occur. So then the probability of your baseball or your uncle's baseball with the U is the probability of them selecting your baseball plus the probability of it being your uncle's baseball. So just plug in what you know. So the probability of it being your baseball, you donate 8. How many are there? There's 50. Plus the probability of it being your uncle's, he donated 12 baseballs and there's still 50 left. So the probability of your baseball is 8 out of 50. The probability of being your uncle's baseball is 12 out of 50. So we just combine like terms. 20 over 50 reduces to 2 over 5. So this one can also be on your test. And then here, no possible of your baseball and your uncle's baseball. So that's why it's mutually exclusive, because there's no possible outcome that could be your baseball and your uncle's baseball if they're only throwing one first pitch. So that's why using the mutually exclusive formula. Okay, and then we'll do the last one and then we're done. Is anyone still writing number 6? Okay, so for number 7, tell whether the outcomes of each trial are independent or dependent events. So a dictionary entry selected at random and an encyclopedia entry selected at random. So after you go to this dictionary and select an entry at random, you go to the encyclopedia and then select an entry at random. So these are both independent events. The reason being is because selecting a dictionary entry does not affect the possible outcomes for selecting the encyclopedia entry. This will also be on your test. So you either have a 50-50 chance of getting this right. Whatever event I give you, is it independent or dependent? All right, other than that, that's pretty much it. You only have 7 problems. As long as you follow what I did, you should get all the problems correct.